Hello, my name is Rosangela Melatto, and I'm presenting today on behalf of a Brazilian team that performed an evaluation of circularity of the adoption of cleaner production in the textile industry. Let me get started with two important concepts, circular economy and cleaner production. According to the Ellen MacArthur Foundation, the circular economy is a systems solution framework that addresses global challenges aiming at eliminating waste and pollution, circulating products and materials, and regenerating nature. Authors such as Ruggieri pointed out that it can be implemented at the micro level, meaning companies and consumers can contribute to this end. Regarding internal production, the production chain, circular economy helps in the economy and preservation of products, components, and materials. According to the UNEP, cleaner production is an environmental strategy of continuous application integrated to the various process, products, and services. Some authors have identified areas in which cleaner production contributes to reduce impacts to the environment. As an example, we may cite cleaner production in the civil construction sector contributes to energy efficiency, in the paper sector to reduce emissions and consumption, reducing waste in the agricultural sector, and reducing emissions and waste in the textile sector. Regarding the adoption of circular economy at the micro level, it's possible to achieve circular business opportunities that improve environmental management and productive efficiency to the company. That is, both circular economy and cleaner production are innovative approaches that gain importance due to their contributions to sustainable performance. Regarding the textile sector, circular economy addresses circular opportunities for materials, facilities, packaging, clothing, and clothing collection programs, involving the production chain from the design, production, consumption, and waste management phases of the product. Strategies to achieve sustainability goals have been discussed by researchers and public sectors. Thus, circular economy has stood out for being a strategy that presents itself as a substitute for linear business models. In this way, specialists in the textile sector have been involved in the development of actions to provide knowledge and opportunities for circular business and to promote awareness of sustainability. In this context, the circular economy as a management approach in the food and textile sectors offers a real opportunity for the reuse of food waste to produce natural fiber that can be used in the production of new textile products. In this sense, the development of natural fibers for textile application from food waste has been one of the best in progress. Globally, the textile sector is of great concern due to the use of natural resources, fossil derivatives, and problems associated with clothing disposal, resulting from population growth. Textiles discarded in landfills or incineration facilities also pose serious environmental risks. So, in order to minimize the effects of environmental impacts, various forms of transformation of textile waste have been used to obtain new textile fibers, such as the use of acetate to transform cellulose-based waste present in paper and cotton. Also, recycled polyester yarn blends and recycled cotton can be used in some fabrics, minimizing the production of virgin fibers. The fast fashion tendency contributes to the increase in the negative impacts for the environment, which are related to the large volumes of water and energy that are consumed in the production and distribution process, including the extraction of raw materials, the production of textile fibers, the weaving, the dyeing, the washing, the end-of-life process. In this context, the mechanical splitting of the textile cellulose can offer a promising strategy to obtain environmental and financial gains, contributing to reduce the pressures that the textile sector faces. This study aims to access the economic and environmental gains that can be derived from the mechanical splitting of cellulose in cotton fabric in a textile company and to discuss the opportunities for the circular economy associated with this method. Thus, There is a lack of studies in the evaluation of the circularity of the adoption of cleaner production at the micro level in the textile sector. Therefore, to contribute to actions aimed at preserving the environment, this study aimed to evaluate the circularity of the adoption of cleaner production in the textile sector to verify the circularity index due to mechanical splitting of cotton cellulose. To achieve the objective, a case study was used as a method, collecting data through process observations and intervals in order to identify the amounts of virgin cotton fiber and the fiber rate. Based on the data collection, it was possible to estimate the circularity index by applying the method proposed by Melatto et al. This study addressed the mechanical splitting of cellulose in cotton textiles in the specific context of a textile company, with the purpose of identifying opportunities for circular economy and attaining economic and environmental benefits that are quantifiable. Before the implementation of the circular economy principles, the company used virgin cotton carrying a negative environmental impact in the abiotic levels that stands for global warming, soil, humidity, vegetation, the abiotic compartment related to life, air due to the generated emissions, water due to the consumption in the irrigation process, erosion due to the cultivation and crops in the linear cycle. The implementation of the principles of the circular economy led the company to focus on the process of recovering fibers by means of recycling and reuse of scrap from fabric in the textile industry, as well as for fabric that is discarded in the end of its lifetime. However, not all fibers are recoverable. The waste is discarded in an adequate manner. In the process, 99% of the fiber is recovered with the original level of quality. The company implemented the process of mechanical recycling for textile waste and consumes energy with the use of perforating equipment, shredding equipment, baling, machinery, compacting, and lighting equipment that generate a negative environmental impact when considering all the compartments: abiotic, biotic, water, air, and erosion. The company also consumes lubricants for the machines, thus adding to a total negative environmental impact. In the case addressed in the study, a total of 99.69% of circularity was obtained by dividing the corresponding to the reduction of the environmental impact by corresponding to the negative environmental impact in relative terms. The data suggests that despite using 100% of recycled fiber in the manufacturing process, there was a loss due to consumption of energy and lubricants. Also, it was conducted a cost analysis that allows for the identification of the reduction in the annual cost derived from the circular economy, considering the recycling of textile waste and recovery of fiber for production. The analysis considered the consumption of cotton for the annual production the before scenario. After the implementation of a circular economy, we observed the volume of direct costs that resulted for higher employees. Consider the costs of lubricants for equipment, the consumption of electric energy, lab tests, food, storage costs, insurance, and indirect costs with the maintenance of machinery, equipment, and facilities. Also, and according to what was mentioned in the environment assessment, the need to discard of fiber added up to a loss in the recycling due to impurities that contaminate the cotton fibers. The results showed savings in virgin cotton fiber obtained through the circular economy at the micro level, meaning cleaner production. Thus, the use of cotton fibers recovered from mechanical splitting, achieving a 15% reduction in the purchase of virgin cotton fiber, indicating an opportunity of 92% circularity in the use of cotton fiber. Therefore, it was seen that the micro-level circular economy in the textile industry has improved the reuse of recovered fibers, being an important opportunity to reduce the environmental impact in the sector. The study supports the notion that the adoption of mechanical shredding for cotton cellulose allows for achieving economic gains and the reduction in environmental impacts when adding the several compartments: biotic, abiotic, water, air, and erosion. We suggest that the future research work should explore other recycling processes for textile fibers and explore both their impacts and circularity. For your attention, thank you.